So we derived the Michaelis-Menten equation. V0 is equal to Vmax into S by Km plus S. So this is the basic equation, and it is used to calculate the Km and Vmax of an enzyme. So now the question is how to calculate this Vmax and Km. So when we purify an enzyme and we try to characterize it, we need to derive these two values, Vmax and Km, for a particular substance. So how to do that? So we can't plot this curve to derive the Vmax because we don't know at what concentration of S it will attain the Vmax, because by the equation Vmax is attained at an infinite concentration of S. So one scientist or researcher working in the laboratory cannot increase the concentration of a substrate to infinite concentration in order to get Vmax. So there is another way to calculate the Vmax from the Michaelis-Menten equation. So if we take the reciprocal of this equation, the equation changes to this. So 1 by V0 is given by this Km by Vmax into 1 by S plus 1 by Vmax. So if we compare this equation to a straight line, take this value as y and plot it in a curve. So 1 by V0 is equal to y, 1 by S is taken as x. So we'll get a straight line with a slope m is equal to Km by Vmax, and the y-intercept is equal to 1 by Vmax. So from this equation, if we take these two important points give us the value of 1 by Vmax and minus 1 by K. So how this point shows that this point is minus 1 by K. So just on this line, all the values of 1 by V0 become 0. So just by putting 1 by V0 at 0 for this point, we get 0 is equal to this value. So Km by Vmax into 1 by S is equal to so I can just write this as 0, hence minus 1 by Vmax is equal to Km by Vmax into 1 by S, implies that so Vmax is cancelled, so 1 by S is equal to minus 1 by K, and this point 1 by S is minus 1 by K. Hence by knowing this point, this value can be derived from a graph, and if we know the value of minus 1 by Km is equal to certain xyz, we can calculate the value of Km. Similarly, let's consider this point. So this point is a point on the y-axis where 1 by S is 0. I mean x value is 0 on this line. So if we put the value of 1 by S is equal to 0, this whole term becomes 0 because 1 by S is 0. So whatever is multiplied by 1 by S becomes 0, is equal to 1 by Vmax. Implies that 1 by V0 is equal to 1 by Vmax. So this value is shown here. Hence, by calculating the value of 1 by Vmax from a graph, we can calculate what is the value of Vmax. So this plot is otherwise called as Line-Weaver-Burke equation. Burke plot. And this plot helps us to determine the Km and Vmax values for any enzyme which follows the Michaelis-Menten equation. So in the next video, we'll see how this rate changes in the presence of inhibitors. So for the time being, we learnt the Michaelis-Menten equation and how to derive Lineweaver-Burke equation from this. Thank you.